Welcome to part 2 of section 3.9. Here we're going to be delving into the derivatives of logarithmic functions, specifically the derivatives of the natural log of x and log base a of x. So let's do a quick review first of what ln means and what log means overall just in mathematics. Ln means natural log, whereas log just means log, logarithmic as the long word. So this is the natural logarithmic function, ln of x. Let's actually first talk about the regular log function. This, in general, if you don't see a base, has a base of 10, unless otherwise written. So if we take a look at like an example, if we had log base a of x equals y, we learned at the beginning of the year that this really means that a to the y equals x. Now, if there's no a written here, it's really just a 10. So that's just a quick recap of logs. A natural log naturally has a base of e, and we wouldn't write a natural log if it had a different base. So it's always going to be a base of e. We don't write the base of e. So in general, if we had the natural log of let's say 20, that really means e to the what? E to what exponent gives us 20. So in your calculator, if you type in ln, there's just a button for ln of 20, that is 2.99. So it's almost 3, because e cubed, or e to the 2.99, is about 20. Remember, e is about 2.718, so you can think of it as almost 3. 3 to the 2.99 would be about 3 cubed, which is 27, so it's definitely a little too big, but 2.7 something to the third, or 2.99, is about 20. So that's just what natural log means. A big thing with natural log is definitely understanding that the natural log of e is just 1, because again, we're thinking e to the what gives us e in this case, which is just 1. The last thing that we need to understand is that the natural log of 1 is 0, because this is saying e to the what, 0, equals 1. So these are two big things that we need to understand here. And for all other natural log of something other than e or 1, we can definitely use our calculator. In that same idea here, the log of 1 does equal 0, because that's asking us 10 to the what, to the 0, equals 1. We can only take the log or natural log of values that are positive. So we can never plug in a negative number. If you try to do the natural log of negative 20 or negative 1, or the log of something negative, it will say error on your calculator, because we never get something out that is negative from a log. Here are the derivative rules, the main part of today's lesson. On your derivative rules sheet, you will definitely be able to see that these are both on there. I have included them just using my own notation with the chain rule built in. So if we take the derivative of the natural log of some function u, the natural log of u, it is technically 1 over u, and then invoking the chain rule times du dx, or u prime. Now this u prime can just be put into the numerator, so it's really the derivative of u divided by u, and that's how we take the derivative of the natural log of something. To take the derivative of the log base a of u, we have 1 over u times the natural log of a times the derivative of u. So we can also, in a similar fashion, write this as u prime over u times the natural log of a. So get those written down on your list of derivative rules. These are going to be the last of the official derivative rules. Let's do some examples. Okay, for numbers 1 and 2, we want to find each derivative. Each is using a natural log. And so the main idea behind natural log to find the derivative is it's 1 over that function on the inside. So it's 1 over 2x, our inside function. Then we need to invoke the chain rule by multiplying by the derivative of what's on the inside, the derivative of u. which is times 2. So we can rewrite this as, again, u is 2x, and u prime is just 2. So it was u prime over u. So we have 2 over 2x, which simplifies to 1 over x. In number 2, we again are going to use the derivative rule. The derivative of the natural log of u is u prime over u. So our u value here is 2x minus 9, and u prime, since we'll need to use the chain rule here, is just a 2 again. I included these examples next to each other to show that u prime ended up being the same, but our final answer looks different because that minus 9 does affect our final answer. So it's u prime over u. And of course, you guys all know better that we can't cancel those 2's the way that this is written. So that is the difference. When we do have more than one term inside our natural log, it doesn't change too much, but the final answer does look significantly different. Here we have 2 other examples. In number 3, we have a power rule, and then we'll have to use the chain rule here. So let's go through this one. In order to find dy dx here in number 3, we have something to the power of 2. So using the power rule, I'm going to bring the 2 out front, keep that inside term the same, and then raise it to 1 less power, which is just the first power. Then we're going to multiply by the derivative of the inside term here. The derivative of the natural log of x is just 1 over x, times the derivative of x, which is just 1, so we don't really need to use the chain rule there, since its own derivative is just 1 up here. So we are done here, but we can make this look a little bit nicer. So our final will be what's in the numerator, 2 ln of x over x. Now these x's cannot cancel. That is because this is a natural log of x. This x is attached to the natural log. If we had a natural log of x here and also one in the denominator, sure, we could cancel the whole ln of x's, but we cannot cancel these x's here because the x in the numerator is a part of the natural log. In problem number 4, we're moving on to a new type of function here. This is just the regular logarithmic function. Here our base is 4, so that's our a value. I rewrote the rule down here. And our u value, the inside function, is x squared. So what I'm going to do is write out all the things we need to know. We need to understand what u is, what a is, and what u prime is. So we can write those 3 things out. Our a value is 4, it's our base. Our u, the inside function, is x squared. And our u prime, or du, is 2x. So now that we have those 3 things for this problem, we can find the derivative of y with respect to x of this function just using the rule. So it's u prime over u times the natural log of a. Now the natural log of 4 is just a number, but since natural log is so messy, like it's going to be a non-repeating decimal, we can just leave it as ln of 4. However, we can cancel these x's here, so one of the x's can cancel. So this x, and then that just turns to an x since it's no longer x times x down there. So a final answer, written nicely, is 2 over x ln of 4. And that is our derivative. For problem number 5, we want to find dy dt for this product here. We have y equals t times the natural log of t. And so we do need to use the product rule because each one of our factors of our product has the variable t in it. So our u value is t, and our v is the natural log of t. Then u prime, the derivative of u with respect to t, is just 1. And v prime, the derivative of ln of t with respect to t, is just 1 over t times the derivative of t, which is just 1. So it's just 1 over t in this case. So now using the product rule to find dy dt, we'll do u times v prime, so t times 1 over t, plus v times u prime, so 1 times ln of t. Cleaning this up, t times its reciprocal is just 1, plus the natural log of t. And that is our dy dt.